Hello, today we're going to be talking about graphing polynomials, specifically by factoring, looking at degrees, multiplicity, end behavior, all types of different things. And our focus is going to be primarily working without a calculator. Now I am going to start out with a little bit of Desmos. We're going to talk about end behavior of graphs and how we can ultimately determine what the ends are going to look like out towards infinity and negative infinity simply by knowing about the highest degree term. So we talked about this a little bit in class before, and I just want to reiterate. My first example here, what I've done is instead of just talking about x to the first where n is 1, I also have an x to the n minus 1 term. That way you can see that that highest degree term is always the one that dictates shape. So right now I have basically n is 1 and I have n minus 1 would be 0, which means I basically have x to the first plus 1. I have a line. Its end behavior is down on the left and up on the upper right. As I move up to 3, still down in the left, up at the upper right. That'd be x cubed plus x squared. As I work my way up to 5, that would be x to the 5th plus x to the 4th, still down, up. X to the 7th plus x to the 6th, down, up. So that highest degree term, x to the 7th, determines the end behavior. If I had a negative x to the 7th, it would be up and then down on the right. So we have talked about these before, and you can see as I move my exponents up, it really just flattens a little bit more through the center, gives me some different shapes, but otherwise the end behavior remains the same. If I change it to even exponents, x squared plus x to the 1st looks like this. X to the 4th plus x cubed looks like this. Notice the end behavior is up, up on both ends. And if I stuck a negative in front of those, it'd flip it down, down. All right. So we've talked about in that class before. I really wanted to kind of start out our discussion with that, so as I am looking at different polynomials, I can get that end behavior out of the way right away. Okay, so we'll come back to Desmos here as we attack some of the different problems. So I'm going to start out, and your note guide may go in a different order. I'm going to kind of grab these in various orders to kind of streamline our process a little bit. We're going to be graphing without a calculator. We're going to test with the calculator just to ensure. Notice this was all multiplied out, unlike the ones that we were doing in class and in our investigation. They were already pre-factored. So this one's already multiplied out. This is a negative x to the 4th. A negative x to the 4th is going to have a shape of end behavior that's down on both ends. So I can say my end behavior, and the notation we're going to use is going to look kind of like an ordered pair. It's going to indicate, since it's a negative x to the 4th, that's going to be like a negative x squared. It's going to be down on the left and down on the right as we look at the graph towards negative infinity and positive infinity. The next thing we're going to look at are the zeros and their multiplicities. Multiplicity is how many factors repeat. And I'll explain here as we go. So in order to find zeros, we set that original equation equal to 0 and we factor. I'm going to factor out a negative x squared as a greatest common factor. And if I do that, that would leave x squared minus 1 inside. Since I have a quadratic, I'm going to break that x squared minus 1 into x minus 1 multiplied by x plus 1. If you're looking back at this, you could freeze that, kind of practice your own factoring. I'm just going to kind of do some of these quickly. So notice we have a factor of negative x squared. We have a factor of x minus 1 to the 1st and x plus 1 to the 1st. So we have 3 separate factors. If we set those each equal to 0, I get divide by negative 1, I take the square root, I get x equals 0, and I call that multiplicity 2, since my exponent was a 2. When we talked about graphing, we talked about how that basically is going to bounce or reflect off the x-axis at that particular value of x equals 0, like a parabola would. This is going to act like an x squared. Okay? X minus 1, multiplicity 1, I'm going to set that equal to 0. I get x equal 1, multiplicity 1. And here I have x plus 1, multiplicity 1. Since it was an exponent of 1, set it equal to 0, I get x equal negative 1, multiplicity of 1. If I add up multiplicity 2 plus 1 plus 1, that'd be a 4. It was a negative x to the 4th curve. That lets me know that I didn't lose track of any of those values. The next thing I'm going to do is I'm going to start my sketch. I'm going to plot my zeros. I have 0, negative 1, and positive 1. I have my end behavior of down, down, which means I'm going to start at the bottom left of my curve. I'm going to end up at on the bottom right when I'm finished. Then I'm going to look at each value independently from left to right. So at negative 1, that's on the far left, I have multiplicity 1. Multiplicity 1 looks like x the first does as it passes through the x-axis. So in other words, it's going to come up from the bottom and cut through like a line, x the first. At 0, we have multiplicity 2. Multiplicity 2 is going to come up, it's going to come back down, and it's going to bounce off like a parabola at 0. I'm not worried about how high this value is. That's either going to take a lot of ordered pairs or a little bit of calculus to determine that maximum value between 0 and negative 1. So I'm just going to draw that up. It's a sketch. It's not going to be perfect. So don't get strung out on how high that value is. Then I'm going to come back up. I'm not going to worry about how high I go. I know I have to loop back down and I have to go through 1. At 1, I have multiplicity 1, which means it's also going to cut through, straight through like x the first. And in the end, we talked about how the end behavior should end at the bottom right. So if I've done this correctly, then I should have a graph that looks like this in the end. So I'll shut that one off, and you can see I end up at the bottom right, start at the bottom left, it bounces off there at the center. If you zoom in, you can see the emphasis, and it crosses at 1 and negative 1. For my next example, I have a cubic. Its end behavior, this is a positive x cubed, so its end behavior is going to start at the bottom left, like our basic parent function x cubed, and end up at the top right and do some stuff in between. I'm going to do a little bit of factoring by grouping to find my zeros. I have 4 terms. Of those 4 terms, I'm going to take the first 2 and the last 2, and I'm going to factor out a greatest common factor from the first 2 of x squared. And if I factor out that x squared, I'll have an x plus 1 left inside. Now in my second pair, I need to factor out a greatest common factor, and it needs, when I'm done, I need to have x plus 1 left inside, or it's not going to work. So I see that if I factor out a negative 25 out of those 2 terms, I would have x plus 1 left over. Now, I started with 4 terms. I'm now down to 2 terms, 2 parts that are being added and subtracted. Of those 2 terms, I have a factor of x plus 1 common. So I'm going to factor out the x plus 1, and I would be left in this term with x squared. And in this term, I'd be left with negative 25. And then that is going to factor into 2 binomials, x times x, and to get a negative 25 and a 0x, I'd have x minus 5 and x plus 5. So I have three different zeros. They're all multiplicity 1. Those add up to x cubed. All right, multiplicities add up to be a total of 3 to match up with my original expression, my original polynomial. So I'm going to find each zero. I have x plus 1 equals 0 to get x equal -1 multiplicity of 1. That's my exponent. X minus 5, set it equal to 0. I'll get x equal 5, multiplicity 1. If I get x plus 5 equal to 0, I'll get x equal -5, also multiplicity 1. Those add up to 3, as I said. Checks out, gives me an x cubed. So if I do a quick sketch of this one, I would go at -1, -5, and +5. I'm going to start at the bottom left because of the end behavior. I'm going to end up at the top right. And all of these are multiplicity 1, which means they're going to cut through without any hesitation like a line. I'm not going to worry about how high I go except to make sure I can clear that next value. And then I go down. I'm not worried about how low I go. It's just a sketch. I cut through like an x to first, and I end up at the top right just like we'd anticipated. If we check out the graph on Desmos, difficult to see at first, but if I zoom back out, you can see I have that multiplicity 1. They don't hesitate at all as we cross through 5, -1, and -5, and my end behavior is definitely down and then up like we'd anticipated. So the next problem I'm going to look at is this cubic. I see a greatest common factor of -x this time. Before we get started, let's talk end behavior. My end behavior before I factor, it's a -x cubed. -x cubed is going to be up and then down. To find my zeros, I'm going to factor out a -x as a greatest common factor, and I would have 4x squared minus 12x plus 9 left over. If I factor that quadratic, 2x times 2x gives me a 4x squared. To check my FOIL and to get a 9, I find that I need a 3 and a 3 to get a 9. My outer and inner products are both 6x. That'll give me that 12x that I need. And a negative in both of those will give me the -12x that I need. So that means I can rewrite this, and this is really important, as 2x minus 3, the quantity squared. That square tells me I have a multiplicity 2 at that 0. If I set -x equals 0, that's x to the first. I get x equals 0, that's multiplicity 1. I set 2x minus 3 equal to 0. I get x equal 3 halves, that's 1.5. Multiplicity 2 because of my repeated exponent of 2 up above. So if I sketch 0, 1.5, my end behavior is up and then down. At 0, my leftmost point, I have multiplicity 1, which means it's going to come in from the top and just cut through. Multiplicity 2 tells me it's going to go down, and then it's going to bounce off the bottom like an x squared does. So I have something that looks like that. Now if we go to Desmos, we can check that. You can see my multiplicity of 2 here at 1.5 bounces as we expected. At 0, it's multiplicity 1. It cuts through with no hesitation. It doesn't matter how close I get to that. It doesn't hesitate at all. and then it comes in from the top and ends up at the bottom right, just as we expected. So as you're going through these, take a minute, look at Desmos or your graphing calculator to verify that these work. Desmos is nice because you can zoom in and out readily. You don't have to reset the window and things like that you have to with your calculator. All right, so let's pick up one more problem. We'll do one more problem where we have to factor. This one I chose. It's a little different with some factoring, and some of you haven't seen this before, so I want to kind of make sure we emphasize this. Our end behavior, we have a positive 5x to the fifth when it's multiplied all out. So our end behavior is going to look like a positive x cubed to positive x to the first. So it's going to be starting at the bottom left and end up at the top right. If I actually start factoring, I can pull out a 5x, and I would be left with an x to the fourth, which a lot of you haven't seen before this way, so I wanted to kind of emphasize it's not a whole lot harder. I pull out a 5 and an x, I would have plus an x squared, and then I would have a negative 2. Now, so to continue finding my zeros, I'm going to break that x to the fourth into an x squared times an x squared. To get the 2, I'd have to have a 2 times a 1. If I think about outer and inner products, notice I have a 2x squared and a 1x squared. So I've got the x squared parts that I need. So really it's just a matter of deciding on signs. In order to get a positive 1x squared and a negative 2, I'd have to have a positive there and a negative there. Go ahead and check your FOIL. You'll see that's the case. This particular part factors further. I'm going to show you that if I didn't see the factors, how I would approach that. This one will not factor. So I'm going to kind of take this a little step further. If I had factored this part, this last part, it would be x minus 1 and x plus 1, both multiplicity 1. That gives me two separate factors. So I would get x equal 1 and x equal negative 1, two distinct values, both multiplicity 1. Another option would have been x squared minus 1 equals 0, x squared equal 1, take a positive negative square root, and I'd get positive negative 1. Notice I took an x squared and I got two separate answers, so they would both have to be multiplicity 1 for them to be two distinct answers. Using that idea and to show you why this one doesn't work, if I take x squared plus 2 equals 0, I get x squared equals negative 2. So I end up with square root of negative 2. So I get plus or minus I radical 2. These aren't going to show up on the graph. Those are imaginary solutions. So I end up with 5x to the first equals 0, so x equals 0 multiplicity of 1. Excuse me, that'll show up on the graph. I get x equal 1 multiplicity 1, x equal negative 1 multiplicity 1. Those will show up on the graph. I get two other values. That gives me my total of 5, my x to the fifth. But those two will not show up on the graph. So if I actually put those on my graph paper, I get 0 multiplicity 1, negative 1, and 1. The end behavior was down and then up. And they're all multiplicity 1, so they should just cut through like a line, something like that. So why doesn't that show up? Well, it is imaginary, and I mean, it shouldn't show up. Let's see if it affects the graph or not. And here, if you look at the graph, you can see it crosses 1, negative 1, and 0. No hesitation at all at any of those values, which means it makes sense to be multiplicity 1. I don't see any strange changes anywhere on the graph. That looks pretty standard. Occasionally you will see, because of like an x squared plus 2 as a factor, you end up with something weird where there may be a little bit of a bump up above the x-axis or below the x-axis, but it will not affect the zeros. So kind of holds true just like we would have expected. I just wanted you to see kind of an odd situation. All right, we're going to do our last one, and this actually ties back to the form when we had an investigation, On the investigation, we had ones that were pre-factored. So we can find the zeros on this one without any real work. What we can't find are the end behaviors. So we have to think about, this is 3x to the first multiplied by an x cubed multiplied by a negative 2x to the fourth. Now if I foiled this, took this times itself 3 times and then this, I would get other terms. But this would be my biggest term, the highest degree. So if I actually multiply those out, I get a negative 2x to the 4th, 5th, 6th, 7th, 8th. So that's an 8, but I also have it times a 3. So I have a negative 6x to the 8th. Let's try that again. Negative 2, 3 to the first would be negative 6. X to the 4th, 5th, 6th, 7th, 8th, negative 6x to the 8th, plus an x to the 7th term, an x to the 6th term, etc. But that negative 6x to the 8th is going to tell me that the end behavior is going to be down on both ends, like a negative x squared and negative x to the 4th, etc. Otherwise, this one's actually easier in that the zeros, we've already done the factoring. So I can say, take negative 2x to the 4th, set it equal to 0, and I get x equals 0, multiplicity of 4. I set my second factor, x minus 1 equal to 0. I get x equal 1, and since it had a 3 as an exponent, I have multiplicity of 3. And then 3x plus 5 equals 0. I'll get x equals negative 5/3. And since my exponent was 1, it was multiplicity of 1. If you add up 4, 5, 6, 7, 8, you'll get the x to the 8 that I promised you. So quick sketch, end behavior down, down. 0, it crosses through. 1, it crosses through. Negative 5/3, which is negative 1 2/3. It crosses through like so. Working from left to right, I'm going to start here at multiplicity 1. I'm going to go through the negative 5/3 and I'm going to cut through with no hesitation. I'm going to go up as far as I want to. I'm not worried about that right now. Then I'm going to go through 0. It's multiplicity 4, so it's going to bounce off like an x to the 4th and flatten a little bit. And then at 1, it's multiplicity 3, so it's going to go up. I don't care how high. It's going to go through and it's going to flatten a little bit like an x cubed and end up down at the bottom as we'd anticipated. So if we run to Desmos quickly, we can find what the graph looks like. We can verify that, and I'm going to leave that to you. Hopefully that gives you some good, strong examples of working with graphing using zeros, multiplicities, and end behavior. Check with Desmos or your calculator along the way and ensure that you're doing this correctly. A lot of times it'll simply be your factors that are the problem. Hope this works out well for you. Enjoy your day.